Hi, welcome back to my algebra class. For today, we will take up the third operation on algebraic expressions, the multiplication of algebraic expressions. We had taken already two operations on algebraic expressions. The first one was addition of algebraic expressions, and the second one was subtraction of algebraic expressions. And before, we also took up the properties of exponents, and we will now apply these properties of exponents when multiplying algebraic expressions. To find the product of two algebraic expressions is to multiply these algebraic expressions. And in multiplying algebraic expressions, we apply the properties of exponents, and we combine the resulting similar terms by operation of addition and subtraction. We now take some examples. Simplify. To simplify means is to perform all the operations involved in the given algebraic expression and combining like terms or similar terms. Number 1, we have 2xy squared multiplied by quantity 3x squared y minus 5xy minus 4x squared y times quantity 2xy squared plus 7y squared. The first step is to remove the grouping symbols by applying the distributive property of multiplication over addition or subtraction. Thus, we multiply each term of this binomial by this monomial from outside, and we apply the left distributive property of multiplication. Multiply the numerical coefficients, and when multiplying the literal coefficients, apply the properties of exponents. We have multiply 2 by 3, that's positive 6. Multiply the literal coefficient x, the exponent of x here is 1. When the exponent is not explicitly written, it's understood that the variable has an exponent of 1. And the exponent of x here is 2. By property of exponent, copy the common base. Common base is x. And add the exponents of x. 1 here plus 2 here is 3. Now multiply the literal coefficient y squared from outside by y in the first term of the binomial. Again, the exponent of y here is 1, but it's not explicitly written, and it's understood that the exponent of y here is 1. Again, by property of exponent, multiply y squared by y, copy the common base y, and add the exponents of y. 2 plus 1 here is 3. Now we multiply this monomial by the second term of this binomial. We start with the numerical coefficients. Positive 2 multiplied by negative 5 is negative 10. We multiply the literal coefficient with x, and x, that's x to the power 2. The power is 2 because the exponent of x here is 1, plus the exponent of x here is 1, and 1 plus 1 is 2. We multiply the literal coefficient y squared by y here, common base is y, and we add the exponents of y. 2 here plus 1 here is 3. For the second term of the given, we remove the grouping symbols. Again, we apply the left distributive property. We distribute negative 4x squared y from the left of this binomial. We multiply each term of this binomial by this monomial from the left. We start by multiplying the numerical coefficients. Negative 4 by positive 2 is negative 8. Multiply the literal coefficients beginning with x squared multiplied by x. The exponent of x here is 1. Copy the common base x and add the exponents of x. 2 here plus 1 here is 3. Now multiply the literal coefficient y by y squared. Common base is y. And we add the exponents of y. 1 here plus 2 here is 3. Next, multiply this monomial by the second term, 7y squared of this binomial. Start with the numerical coefficients. Negative 4 by positive 7 is negative 28. And this term has no x, so we multiply x squared y by y squared. Copy the literal coefficient x squared and the common base y, and add the exponents of y. Exponents of y are 1 here plus 2 here is 3. After removing all the grouping symbols in the given algebraic expression, you inspect the resulting products for similar terms and combine these similar terms by addition or subtraction. We have two terms with x cubed, y cubed. This term and the third term are similar terms. Hence, we add their numerical coefficients. 6 plus minus 8 here is negative 2. And copy the like or similar literal coefficient x cubed, y cubed. X cubed, y cubed. The second term and the last term are also similar terms, so we combine these similar terms by adding the numerical coefficients. Negative 10 plus negative 28 is negative 38. And copy the common literal coefficient x squared y cubed, x squared y cubed, x squared y cubed. And this is the simplified form of the given algebraic expression. When after we have taken factoring, the final answers are usually given in factored form. After we have taken factoring methods, we will always write the final answer in factored form. We take another example for multiplication of algebraic expressions. Consider negative 3p squared cubed multiplied by 2p minus 5 cubed to the power 2. The operation involved in this algebraic expression is multiplication. We have not taken special product rules, but the square of this binomial 2p minus 5q can be performed easily by using a special product rule. But for now, we use the definition of exponential notation. and long multiplication. So this given algebraic expression is the same as negative 3p squared q. By property of exponential notation, the square of 2p minus 5q is the same as multiplying 2p minus 5q by itself twice. So we rewrite 2p minus 5q squared as 2p minus 5q multiplied by 2p minus 5q. We multiply 2p minus 5q by itself 2 times because here the exponent of 2p minus 5q is 2. Now to multiply these factors, you may start by multiplying negative this monomial by this binomial, or multiply these two binomials. I will start by multiplying negative 3p squared q by this binomial. We apply the left distributive property of multiplication over subtraction. We start by multiplying the numerical coefficient. Negative 3 by positive 2 is negative 6. P squared by p squared q multiplied by p. Common base is p. By property of exponent, copy the common base p and add the exponents of p. 2 here plus 1 here is 3. Multiply by q. And we write q only because the first term of this binomial has no q. Now multiply this monomial by the second term of this binomial. Start by multiplying the numerical coefficients. Negative 3 multiplied by negative 5 is positive. Positive 15. Multiply the literal coefficient p squared q by q. This one has no p, so we retain p squared. And multiply q by q. Common base is q by property of exponent. Copy the common base and add the exponents of q. 1 here plus 1 here is 2. And this product of this monomial and this binomial, we multiply by the third factor, a binomial 2p minus 5q. And we will apply long multiplication. We distribute each term of the first binomial by each term of the second binomial, and we add to that product the product of the second term of this binomial multiplied by each term of the second binomial. We further simplify this product by, I will start by multiplying the first term of the first binomial. Negative 6p cubed q. I will multiply it by each term of the second binomial. We have negative 6 by positive 2. Negative 6 by positive 2 is negative 12. Multiply the literal coefficients p cubed q multiplied by p. Common base is p by property of exponent. Copy the common base and add the exponents of the common base. 3 here plus 1 here is 4. And the other factor is q. Now multiply the same first term by the second term of the second binomial. Multiply negative 6p cubed q by negative 5q. Multiplying first the numerical coefficients, negative 6 by negative 5 is positive 30. Multiply the literal coefficients, p cubed q multiplied by q. This term has no p. So in the product, we only have p cubed. And multiply the literal coefficient q. Q by q, common base is q. And add the exponents of q. 1 here plus 1 here is 2. Now we multiply the second term of the first factor of binomial. We multiply the second term by each term of the second factor, also a binomial. We start with 15 multiplied by 2 is 30. Multiply the literal coefficients, p squared q squared multiplied by p. We only apply the property of exponent to the product p squared and p. Common base is p. And add the exponents of p, 2 plus 1 here is 3. And multiply by the literal coefficient q squared. Now multiply positive 15 by negative 5, that's negative 75. Negative 75, multiply the literal coefficients, p squared q squared multiplied by q. This term has no p. So we just write p squared. But we apply the property of exponent to the product q squared and q. Common base is q. And add the exponents of q, 2 here plus 1 here is 3. And we get q cubed, or q to the power 3. Now inspect we have removed the grouping symbols. Inspect the product for common terms, like terms or similar terms, the terms with the same literal coefficients. The middle terms are similar terms, their common literal coefficient is p cubed q squared. Hence we combine these two middle terms that are like terms. The first term is as is, negative 12 p to the 4q. And to combine similar terms, we add the numerical coefficients. 30 plus 30 is 60. And copy the common literal coefficient p cubed, q squared. The last term is the only term with this literal coefficient. So it remains as is, negative 75 p squared q to the power 3. This is the product of the given expression in number 2. Again, after we have taken factoring and methods for factoring algebraic expressions, we will write our final answer in factored form. We take a third and last example for multiplication of algebraic expressions. Consider number 3. We have 2m multiplied by 3n minus 4m plus 5 minus 3m multiply by 6n plus 7m minus 2. Again, the first step is to remove the grouping symbols by applying the distributive property of multiplication. For this first product, multiply each term of this trinomial by this monomial 2m. And start by multiplying the numerical coefficients. 2 by 3 is 6. Multiply m by n, mn. There is no need to apply the property of exponents when multiplying m by n because they have different base. So we simply write the product of m by n, m multiplied by n as mn. Now multiply 2m by negative 4m. Positive 2 by negative 4 is negative 8. Now we apply the property of exponent by in multiplying m by m, common base is m. Add the exponent of m, 1 here and 1 here is 2. 2m multiplied by 5. We simply multiply the numerical coefficients 2 plus 5. 2 multiplied by 5 is 10. Multiply by m. Now we distribute negative 3m to each term of the second trinomial. Or we remove the grouping symbols by applying distributive property of multiplication. We multiply negative 3 by positive 6 is negative 18. And we multiply the literal coefficients m by n is mn. Negative 3m multiplied by the second term of this trinomial. Multiply the numerical coefficients, negative 3 by positive 7 is negative 21. And we apply the property of exponent to multiply m by m, common base is m. And we add the exponents of m, 1 here plus 1 here is 2. And 3m multiplied by negative 3 by negative 2 is positive 6. And multiplied by the literal coefficient m. We have removed the grouping symbols by applying the distributive property of multiplication and properties of exponents. Now we check if there are similar terms that we can combine in this product. We start with the terms with mn. 6mn and minus 18mn are similar terms. They have common literal coefficient of mn. So we add the numerical coefficient 6 minus 18 is negative 12. And the common literal coefficient is mn. The second term, negative 8m is squared, and the second to the last term, negative 21 m is squared, are like terms. Their common literal coefficient is m is squared. Thus, we add the numerical coefficients, negative 8 plus negative 21 is negative 29. And copy the common literal coefficient, m is squared. And this term, positive 10m, and the last term, 6m, are like terms, so we combine them by adding the numerical coefficients. 10 plus 6 is 16. Common literal coefficient is m. Hence, this is the simplified form of this given algebraic expression. And we can write this in factored form after we have taken the methods for factoring. For your practice, please try the following exercises. Simplify. Again, to simplify this is to remove all the grouping symbols by performing the operations involved in the given algebraic expression. When there is a grouping symbol, remove the grouping symbols by applying multiplication, and then combine similar terms by performing addition or subtraction. Number 1, we have 3a times quantity, 2a cubed plus 5b squared, minus ab, minus 2b times quantity, 3ab minus 7a squared. Here you apply the left distributive property. Multiply each term of this trinomial by this monomial 3a. Apply the properties of exponents. Also remove the grouping symbols by performing the operation multiplication and applying the property of exponent. And after you get the product of this and the second term, combine similar terms by addition or subtraction. Number 2, we have a square of m squared minus 2n. You write this square of m squared minus 2n as the product of m squared minus 2n by itself. That means you multiply a square of m squared minus 2n means you multiply m squared minus 2n by itself 2 times. And for the second term, remove the grouping symbols by performing multiplication and applying properties of exponents. After you simplify each term, combine like terms or similar terms. In number 3, we have the product of negative p squared q and square of p plus 3q. First, you rewrite the square of p plus 3q as the product of p plus 3q and p plus 3q. And perform the operation multiplication. Number 4, x times the square of x plus y minus y times the square of x minus y. You write square of x plus y as x plus y times x plus y. Hence, the first term is x times x plus y times x plus y. Also, rewrite square of x minus y as x minus y times x minus y. Hence, the second term will be minus y times x minus y times x minus y. Perform the product, the multiplication in each term, and combine like terms or similar terms by addition or subtraction. If you have question about the lesson today on multiplication of algebraic expressions, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison. Thank you.